This video is going to be about conditional and biconditional statements. So here's an example with a conditional statement. We start out with two statements. Statement P, today is a holiday, and statement Q, the store is closed. Now I can put these two statements together into one statement, a conditional statement, sometimes called an if statement, and it's going to be, if today is a holiday, then the store is closed. Or I could just say, if P, then Q. And I can write this with symbols. I can just put a P in and an arrow and a Q, with the arrow going from the P to the Q. And this is read as if P, then Q. Sometimes it's read as P implies Q. Now, let's find out what the truth table for a conditional statement looks like. So to do this, I'm going to need a column for the truth values of P, another column for Q, and a third column for if P, then Q. Let's put in the values, the possible values for P and Q. So P and Q might both be true, or P might be true and Q might be false, or P might be false and Q might be true, or they might both be false. And now let's see what the truth value for if P then Q, what those values are going to be. So what we're doing is we're thinking in terms of the conditional statement, if today is a holiday, then the store is closed. And we want to see whether the expectations we would have for different conditions are met. So here's what I'm getting at. If I know that today is in fact a holiday, and the store is closed, then my expectation has been met. I expected the store to be closed because today was a holiday. So this is a true statement. If today is a holiday and the store is not closed because Q is false, then my expectation has not been met. I expected that since today was a holiday, the store would be closed, and the store was not closed. So this is a false statement. I'm going to jump down to the condition where they're both false. So today is not a holiday and the store is not closed. Well, I didn't have any reason to expect the store to be closed because today was not a holiday. So that's also going to be true. The condition that gives people a little bit of difficulty sometimes is if P is false and Q is true. In other words, today is not a holiday, but it's true that the store is closed. Now, you might have expected that if it wasn't a holiday, the store would be open. But the statement we started with is, if today is a holiday, then the store is closed. We didn't say that was the only reason the store might be closed. There might be other reasons. Okay? So, in other words, we have no reason to know, just because today is not a holiday, that the store is definitely going to be open. The store could be closed. So this is considered to be a true statement. You might want to drill this one a little bit for yourself, because that's the one that gives people trouble. Okay? When P is false and Q is true, you've still got if P then Q being true. Okay? Now, we've also got something called biconditional statements. Biconditional statements work like this. We've got statement P, 5 plus 5 equals 10, and statement Q, 2 times 5 equals 10. Now, if you think about it, I could, given these two statements, I could say, if 5 plus 5 equals 10, then 2 times 5 equals 10, and that in fact would be true. I could also state them in the other direction. If 2 times 5 equals 10, then 5 plus 5 equals 10. Now, if I can take both of these statements, reverse them, and get the same result in a conditional statement, this is what we call biconditional. We can say this as 5 plus 5 equals 10 if and only if 2 times 5 equals 10. Or I could say it in the other order. 2 times 5 equals 10 if and only if 5 plus 5 equals 10. If I want to write that symbolically, I'm going to have a P and a two-headed arrow and then the Q. So the arrow points in both directions, both to the P and the Q, meaning basically I'm taking two regular conditional statements, putting them together, one in one order, the other in the other order, and so I'm combining them into a biconditional statement. And again, when this is read, usually they'll say something like P if and only if Q. And here's what the truth table for this looks like. So we'll have the values for P, the values for Q, and the values for P if and only if Q. Let me fix that symbol so it looks a little better. Okay, so once again, P and Q might both be true. Or P might be true and Q might be false. P could be false, Q could be true. And my last option would be that they're both false. Okay, well, if they're both true, if it's true that 5 plus 5 equals 10, and it's true that 2 times 5 equals 10, then we're going to have a true statement. If I know that 5 plus 5 equals 10, I can expect that 2 times 5 will equal 10. And similarly, if I know that 2 times 5 equals 10, I can expect that 5 plus 5 will equal 10. Now, when I have one statement true and the other statement false, so in other words, I know that 5 plus 5 equals 10, but it turns out that 2 times 5 does not equal 10, well, that's not going to meet my expectations. So that's false. In the same way, if I find out that 5 plus 5 does not equal 10, but 2 times 5 does equal 10, then I'm going to have a false. Okay, so if either one of either the P or the Q is false, you're going to have a false. If they're both false, however, it's going to be true. If 5 plus 5 didn't equal 10, I'd have no reason to expect that 2 times 5 would equal 10. Thinking of it in the other direction, if 2 times 5 didn't equal 10, I'd have no reason to believe that 5 plus 5 would equal 10. So when they're both false, my biconditional P if and only if Q is going to be true. Okay? So you might want to go over this a little bit just to make sure you're comfortable with it. But in a lot of ways, if you put in good examples, it's basically just common sense. Okay, that's it for now. Take care.